Now, we're going to talk about, well, what's the average? Suppose I wanted to know the average velocity of the first 5 seconds of motion. So what if I want to know the average velocity from 0 to 5 seconds? Well, you'll notice from 0 to 5 seconds, which is from here to here, there is no one line. It's a bunch of lines, a bunch of different parts of motion. But you can still find the average velocity between those times, even though this does some crazy stuff. Because the definition of average velocity, again, is just change in distance over change in time. Final minus initial. Yes, there was all kinds of stuff going on in between, but average velocity between 0 and 5 seconds would be, all right, well, what's our starting positions? What's our final positions? Well, our final position is here, negative 4.0. And we have to subtract our initial position, which was 2.0. And our times, well, our final time was 5.0 seconds, and we started at 0 seconds. And so if I do this, I end up with negative 6.0 over 5.0, which is about negative 1.2 meters per second. Now that motion from 0 to 5 is not constant motion. It's not nice and constant. It's changing in a bunch of different ways. And so the instantaneous velocities between here and here are different. Obviously, we went over that. Instantaneous velocity here was, that's section 0. Instantaneous velocity here was, what did we say it was? I think it was 1, and here was negative 4. But overall, from here to here, final minus initial, average velocity of negative 2, negative 1.2 meters per second. So keep that in mind. Sometimes in these graphs, you're going to get something like this, where the motion is just kind of like a squiggly line. You not even know if it's a function. It has really no kind of discernible relationship. And you're going to be asked about it. Well, it's still a valid motion graph. We have an object that started way behind the origin, so it was behind the 0 line, and it starts to move towards the origin. So it is moving forward, even though it's in the negative portion of the displacement graph. It is moving forward because it goes from, well, maybe here move backwards for a little bit, just a moment, like real, but that's really, but overall, it went from behind the starting line and finally got to the starting line. And there's no real way I can find a slope here. It's a wacky line. There is no straight line there, so there's no slope of this. So I can't really find the constant velocity. There is no constant velocity here. There is an average velocity between 5 and 7 seconds. And you can do that. You could say, okay, well, the average velocity between 5 and 7 seconds is, well, final minus initial. So final position is 0.0 minus the initial position is 4.0. Now be careful. Sometimes, because average velocity is final minus initial, sometimes you're going to minus a negative start point, so be careful of your sign. That would end up being positive overall, wouldn't it? And then you're going to go from 7.0 to 5.0 seconds, 2 seconds. And so you end up with 4.0 over 2.0. That's positive, by the way. You did travel forward. And so you have an average speed, velocity I should say, of 2 meters a second. So we have an average velocity 2 meters per second from here to here. So, not constant motion, but I can find an average motion. Notice, you know, in here, we have it moving, you know, here it's not moving all that great. How do I know that? Well, there's not much slope to this line, right? It's not really moving all that great here. It's moving very slowly. It's kind of creeping towards the origin, just slightly. But then suddenly we have a little burst of speed here. So even though we won't know numbers, conceptually we can see like, oh, okay, so we're moving kind of slow, creeping. It's got a slight kind of like positive upwardish kind of kind of feel to it. And then suddenly, whoo, it moves pretty quick in a little bit of time. And then it kind of slows down a little bit before it actually reaches the origin. So despite the fact that I can't really put numbers to it right now, I can just get a feel of the motion by just looking at, well, how sloped or not sloped is that motion on the graph? And then lastly, we get back to the origin and then we have this kind of motion, this nice kind of parabolic shape. And when we see a nice parabolic shape like this, now it can be like this, it can be downward, it could be parabolic like this. When we see a nice parabolic shape, usually that means there's a nice consistent acceleration. And we're going to learn more about constant acceleration just a couple days. But unlike this erratic motion, it is not a constant velocity, but it is a nice smooth motion. All right, you're either speeding up nicely or you're slowing down nicely. So here we go from E to F, and again, going from E to F, I can't take a slope of a straight line between these. I can't find a nice constant velocity between E and F. It's not there. I can again find an average velocity. So average velocity, I keep doing that, I keep skipping the V. So again, I can go final minus initial. So I go up to 8 minus, I start at 0, and I do this all in from 11 to 7 seconds, that's 4 seconds. And this ends up being 8.0 over 4.0, and so 2.0 meters per second. So check that out, though. We went from here to here in this wacky motion, and we had an average velocity of 2 meters a second. We go from here to here, and we also have another average velocity of 2 meters a second. The motions look very different, but the average velocity is the same. And so that's important.